Okay, today we are going to be covering 10.2 and 10.3, which are our last two sections, which means on Thursday of this week, our Zoom will be covering reviewing for your final exam. I will be sending out an announcement in an email later today that covers everything you're going to need to know about your final exam, when to take it, how to send in your scratch work, everything. Because if you don't send in scratch work with your exam, you get 0 credit for your final exam. So I have to have the scratch work. They're making it a department policy. For anyone who doesn't turn in scratch work, there is no credit on your final exam, which means you won't be able to pass the course. Okay, so I'll put all this in the email and the announcement later today on how and when you'll be able to do all this. Now, 10.2. Okay, so let's go back, since it's been since Thanksgiving break, on the last things we covered in 10.1. What we covered in 10.1 was radicals, square roots mostly, some cube roots and things like that. Okay, when we're talking about a square root, the numbers that we have dealt with so far have been what is called perfect squares, which means the number underneath the radical symbol is what's called a perfect square, which means there is a number times itself that will give you 25. Well, what is the square root of 25? The number that times itself is 25 is 5. What we're going to lead into today for 10.2 is how to write a radical as an exponential expression, which means a number that has an exponent. If you are a radical, you can also be written as an exponential expression, a number with an exponent. Your exponent is going to be a fraction. So this number right here, let's just do the same thing here. It's the square root of 25. So 25 will be my what's called the base. So when I am going from a radical to rewriting it as a square root, my exponent, like I said, is going to be a fraction. It's going to have a numerator and a denominator. The denominator of that fraction is going to be what root is being taken. And the square root is the second root. It's like it says, what number times itself 2 times is 25. So taking the square root of something is the same thing as taking the second root of that number. Now, when we are just talking about square roots and cube roots and things like that, the numerator of this fraction is going to be a 1. Taking the square root is the same thing as raising that number to the 1/2 power. So 25 to the 1/2 power is also 5. Okay? Now, let's do a couple more of these. Let's see, how could you rewrite the square root of 64 as an exponential expression, a number with an exponent instead of a square root? So this would be 64. If it's square root, that means 1/2 power. So what does that mean? It doesn't mean half of 64. It means the second or square root of 64. So what number? These two things mean the exact same thing. So what number times itself 2 times is 64? 8. Okay, now let's go to our homework. The first one. Is 16 to the 1/2 power. Remember, raising something to the 1/2 power is the same exact thing as taking the square root of that number. So 16 to the 1/2 power is 4, right? It's not half of 16. Again, that's the most common mistake is people want to take half of 16. It is not half of 16. It's 16 to the 1/2 power, which means what number times itself is 16, which is 4. Okay? Now, I can also do, it's not always 1/2. It could be 1/3 power, which means what would be the cube root? Let's try one of those. Let's say we have 27 to the 1/3 power. Again, what I'm trying to do is find the number when I multiply it 3 times together, it gives me 27. Not 1/3 of 27. That's not going to give you the right answer. What number times itself 3 times is 27? Or in other words, what is the cube root of 27? This is the same exact thing as saying cube root of 27. What number times itself 3 times is 27? 3 is, right? 3 times 3 is 9, times 3 again is 27. Okay, let's look at number 2. You have 32 to the 1/5 power. So again, what does that mean? It means what number times itself 5 times is 32. So let's think about that. If I'm multiplying a number together 5 times and I'm only getting to 32, it's not going to be a big number, right? Because once you start multiplying numbers together, doesn't it get big fast? It does, right? Your numbers start growing exponentially. That means really fast. So I need to find the number. If I multiply it together 5 times, gives me 32. Let's try 3, just to try a number, just a shot in the dark. Let's see what that would be. If I multiply 3 together 5 times, let's see, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I'm already too big. 81 times 3 is what? 243. So 3 to the 3rd power is already to 243. So 3 is even too big. So let's try 2. So let's see, 2 times 2 times 2 times 2 times 2. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Oops. Which means what? 2 to the 5th power is 32, which means what number times itself 5 times gave me 32? 2 did. Okay? Let me get my calculator real quick. Okay, so let's think about this. Is there a way to do this in our calculator? For instance, if we get numbers that are really, really big and we don't want to write out several numbers several different times to see if they multiply to get us what we need. So let's try that last one in our calculator. 32 to the 1/5 power. We already worked it out. We know it's 2. Let's see if we can do that in our calculator. So just go to your main screen and we're going to type in exactly what you see on this board. So 32. Now, remember how you get up in your exponent? This button right here. So you see how I put your cursor up in the exponent. What do I need my exponent to be? I need it to be 1/5. Well, just type that in. How do you type in 1/5? 1 divided by 5. So look, 32 to the 1/5 power equals 2. So your calculator can do these problems. Okay? For instance, you're going to want us to be able to do that on a problem like number 3 when you have 6,561 to the 1/4 power. So I can start off and say, okay, let's start off with 3. 3 would be too small, right? You're trying to find the number, if you multiply it together 4 times, gives you 6,561. That's why I have my calculator, right? So what do I need to type in? 6,561. Go up in your exponent. What does your exponent need to be? 1 over 4. So just type that in, 1 divided by 4. Hit enter. Your answer is 9. Okay? Now, let's look at number 4 and see what it means. I have 64 over 81 to the 1/2 power. Now remember, raising something to the 1/2 power is the same exact thing of taking the square root of it, right? Remember, we did square roots of fractions in 10.1. You just think of them as separate problems, kind of, right? This is the same thing as saying the square root of 64 over the square root of 81. They're both perfect squares. Just take the square root of each one of them. So what is the square root of 64? 8. And what is the square root of 81? 9. So that's the same thing as raising it to the 1/2 power. That means take the square root of 64, which gives me 8, and take the square root of 81, which is 9. Okay? All right, let's look at the difference between number 5 and number 6. We'll do them both in our calculator. One will give us a solution, and then one's going to tell us something must be wrong. Okay? So, here's a problem like number 5, and here's a problem like number 6. So let's think about what this means. So this means, let's type them both in our calculator and see what we get. Let's look at this one. So I'm going to do just like it says. I'm going to put that in parentheses because that is extremely important. Anytime you're dealing with radicals or numbers that are exponents that are fractions, anytime you have a negative, that's when you want to put the open parenthesis, negative 3125, close, then raise that to the 1/5 power. So go up into your exponent and then type in 1 divided by 5, hit enter. You get -5. Let's do this one. Again, open parentheses, -16, close. Now, what is my exponent? 1/2. So go up into your exponent, 1 divided by 2. Look what you get. Error, non-real answer. So let's talk about why one of them has a solution and why one of them doesn't. What are we trying to find on this one? The number, if you multiply it together 5 times, gives you -3125. Let's see, -5 times -5. If I multiply these numbers together, look, if you multiply 2 negatives together, what's going to be your answer? It's going to be +25. So look what happens. First here, -5 times -5 is +25. So when you multiply that times -5, you get -125. -125 times -5 gives you +625. But when you multiply it this last time, +625 times negative, it's a positive times a negative, gives you that negative 31.25 like you want. So here's the rule. If you multiply a negative number times itself an odd number of times, you're going to end up with a negative solution, right? A negative times a negative is a positive, but when you multiply it that third time, that's what turns you back into negative. What happened when you did it the fourth time? Turn back to positive. The fifth time, turn back to negative. So if you multiply a negative number an even amount of times, you're going to end up positive. But if you multiply an odd number of times, you're going to end up negative, which means if this number is odd, you can do a negative number because you just say, oh, that just means my answer is going to be a negative number. If I multiply a negative number odd times, I'm going to end up negative. For that same reason, if that number is even and you have a negative inside your parentheses, there's not going to be a number that's going to do that for you, right? Because what is, so the square root of positive 16 is 4. So you're saying, why wouldn't my answer just be negative 4? Well, try it. What do you get when you multiply negative 4 times itself? We have a negative times a negative, which makes it positive 16, which is not what we need. We need negative 16. So the rule is, if this number is even and you have a negative inside those parentheses, then the answer is going to be non-real. Okay? Number 7 says write the following exponential. So it's going to give us the number, the base number with an exponent and say, okay, now take it back to being a radical. So I've got 23 to the 1/2 power. It doesn't say to solve it. It doesn't say to find the answer. It just says to rewrite this as a radical. So what is raising something to the square root, raising something to the 1/2 power mean? Means you're taking the square root of it, right? 1/2 means square root of 23. So that is your answer. You're just rewriting that as a radical. All right, number 8, same thing, right, with radicals. This time you have 5 to the 4/7 power. So we have something we haven't seen yet. All of the problems that we've worked so far have had this number up in the top of the exponent be a 1. This number is actually, so this number tells me what root to take of the base. This number is going to be that root number's new exponent. So let's see, what root am I taking of this 5? That's your root number. So let's see. I have a little thing like this with a 7 in the root number. Seventh root of 5. Now, this means I want to raise all of this, the 7th root of 5, to the 4th power now. So I'm going to put parentheses around that and raise that to the 4th power. How am I going to type that into MathLab? Let me share my screen real quick. Just to make sure that you can see how to type that in. Let's see, we're in 10.2. And we are on number 8. So let's see, this says 9 to the 3/8 power. So let's look at that one. And write it out before you try to type it in. So let's see, I want to take the 8th root, right? That's your root number. The 8th root of 9. Now, I want to raise all of this. That's your new power for all of this. So in parentheses, raise it to the 3rd power. So I want to have open parentheses, 8th root of 9, close parentheses, 3rd power. So let's see, how are we going to type that in? So let's go in our answer box. Now look down here at the 2 different roots. You have just a standard square root. Then right to the right of that, do you see how you have a little blue box in this root area? That's what you're going to want, right? Now, the first thing we're going to need is open parentheses. Now, since we're doing 8th root instead of square root, I'm going to hit that one that has the blue boxes in the root area and the number underneath the radical. So let's see, I'm putting the little 8 in the house. Then under the house, I have a 9. So I arrow to the right, then I'll put a 9, then I'm going to arrow to the right again to get out of the radical, right? I'm done with typing underneath that radical. I'm going to close my parentheses, and now I need 3rd power. So remember how to type an exponent. Again, it's down here in your toolbox. This number that has a little, it's called superscript. Put your cursor in your little blue box up in that top area and put in that 3. Okay? All right, last problem, number 9. You have simplify by first converting to a rational exponent. I've got the square root of r to the 30th power. So first of all, let's rewrite that as an exponential expression. What does square root mean I need to do? It's the same thing as raising what's underneath here to the 1/2 power. So I have r to the 30th to the 1/2 power. Now let's recall our exponent rule. If you are raising an exponent to another exponent, you're going to have to multiply those exponents together. So let's see. I have, what do I need to multiply? 30 times 1/2. So just do that on your calculator if you want. 30 times 1/2, you get 15. So it's not, the answer is not just 15. The exponent turns into 15. So r to the 30th to the 1/2 gives me r to the 15th power. So let's look at another one. So what did you essentially do to that 30? Cut it in half, right? That's a good shortcut rule for later on. When you are talking about exponents only, you want to just divide that exponent by whatever root you are taking. So if you are taking the square root, which is kind of like a hidden 2 right there, the second root, just divide your exponent in 2. Okay? So let's see. What if you have the square root of x to the 16th power? That's not the square root of 16. That's the square root of x to the 16th. So I'm going to use that shortcut rule for exponents. if I'm taking the square root of an exponent, I'm just going to divide that exponent by 2. So that's going to give me x to the what? If I divide your exponent by 2, it'll give me x to the 8th power. So here's the difference. I cannot use that exponent rule right here. I only use that shortcut rule by dividing your exponent by 2 in my exponent. The square root of regular 16 still says what number times itself is 16. It's still 4, right? This big number is still 4. The square root of y to the 16th. Now I can use my exponent rule that says to divide my exponent by 2 to get y to the 8th. So don't confuse the two. We only use that divide your exponent by 2 rule when you're talking about square roots of exponents only. Okay, so I'm going to stop this one and then I'll start a new Zoom for 10.3.